Hello everyone. Today we are going to discuss the surface area of a three-dimensional object. So the formula for finding the surface area is given here. So this section is following double integrals over rectangles. We finished that, and then we finished double integrals over general regions, right? And then we finished double integrals over double integrals using polar coordinates, not over, using polar coordinates. Now we are discussing the surface area, okay? And the formula for finding the surface area is given by either this or that. Now I'm not going to go into the derivation of the formula because it gets complicated. Remember, this is an extension of the idea in Calc from Calc 2. In the Calc 2, when your curve was rotated about the x-axis, or it was when it was rotated about the y-axis, the surface area was evaluated. And in Calc 2, if you rotate it about x-axis, your surface area was integral over the a to b 2 pi y and the ds, where the ds was the arc length, okay? And if you rotate it about y-axis, then your surface area was integral a to b 2 pi x ds, where your surface area was, where your arc length was ds, okay? So it in a way it looks similar to that, but it is different from that. And I hope you remember your arc length was square root of 1 plus dy by dx squared, or it could have been, depending on how the function was defined, it was dx over dy squared. Okay, it depends on how the function was defined. So surface area in Calc 3 looks a little bit similar to the surface area of surface of revolution in Calc 2, but not a lot. Okay, but I cannot give you the same argument to proving this formula. But however, we will memorize this formula and go from there. Okay, let's look at an example problem here. This is, you want to find the surface area of the part of the paraboloid z equals x squared plus y squared that lies under the plane z equals 9. Okay, so now if you look at it, your surface area formula was I think double integral over the domain square root of 1 plus dou z over dou x squared plus dou z over dou y squared. And you have a dA here, right? So you have dou z over dou x is gonna be 2x, and dou z over dou y is gonna be 2y. Okay, then you have the surface area is gonna be integral over the domain 1 plus, you have 2x squared plus 2y squared, and this is under the domain D, and this is dA means you get dx dy. Now the question is, what would be the limits of integration? How would I go with the limits of integration? Now if you look at it, this is x-axis, y-axis, z-axis. So z can be varying from, these are some of the squares, so z has to be 0 or positive, so your paraboloid would be like that, and at 9 it will be like that, right? Are you with me now? But if you look at in 2 dimensions, you have, if you put it like, you get x squared plus y squared equals 9, so that means this is going to be 3, 3, negative 3, negative 3. You can look at it like that, okay? So x varies from negative 3 to 3, y varies from negative 3 to 3, or you can go as radius varying from 0 to 3, or theta varying from 0 to 2 pi. okay, whichever way you want to go. Let's see whether we have to use the polar or the rectangular coordinate. So that's going to be integral double integral over d and square root of 1 plus 4x squared plus 4y squared dA. Now if you use a rectangular, if you integrate straight away, it is going to be very difficult. I'm not even going to try. You can try it if you are interested. So I'm going to make a substitution. X equals r cosine theta, y equals r sine theta. So that means I get x squared plus y squared is going to be r squared. And I know that dA is going to be r dr d theta. We did this yesterday, okay? This is a good motivation as to when the rectangular, when the double integration using the x, dy fails, you can try the polar coordinates. And in this case it works, okay? Not every case, maybe, but in this case. Square root of 1 plus 4r squared, then you have r dr d theta, where your limits of integration is going to be from 0 to 3, radius is going to be from 0 to 3, and theta is going to be from 0 to 2 pi. Let's go ahead. So now you can, this is, I am treating this as a separate integral, r square root of 1 plus 4r squared. This is, you can do it using u substitution. So you get 1 plus 4r squared is u, du dr is going to be what, 8r. So dr is going to be du divided by 8r. So that's going to be r times square root of u, dr is going to be du divided by 8r, and r gets cancelled out. So you get 1 over 8. Square root of u du, so upon integrating you get 1 over 8 u to the 1 half plus 1 divided by 1 half plus 1. Oh, I'm off the screen, I didn't see that. So that would give you, am I on the screen? Yes, so that will give you 1 over 8 u to the 3 half divided by 3 half. So upon simplification you get 1/4 u to the 3 half. Now back substituting u is 1 plus 4r squared, you get 1/4 1 plus 4r squared to the 3 halves, okay? So this is going to, you're going to use that where you're going to use that here. So that's going to be integral 0 to 2 pi. You get 1/4 1 plus 4r squared to the 3 half, where your limit of integration is going to be from 0 to 3 d theta. So that's going to be 1/4 as a constant, so that steps out of the integral sign. So that's going to be 0 to 2 pi. Upon substituting the limits of integration, you get 3 squared is 9, 9 times 4 is 36, so you get 37 to the 3 half minus, when you substitute r is 0, you get 0 times 4 is 0. I hope I'm right. So that's going to be 1 d theta, okay? So so upon integrating, this whole thing is a constant, so you can pull it out. So you get 37 to the 3 halves minus 1 divided by 4 integral 0 to 2 pi d theta. So that's going to be 37 to the 3 half minus 1 divided by 4 times 2 pi minus 0. So that's going to be 37 to the 3 halves minus 1 divided by 4 times 2 pi, where your limit of integration gets cancelled out. So this is going to give you pi times 37 to the 3 halves is 37 times square root of 37 minus 1 all over 2. So that's how you find the surface area for this paraboloid that lies under the plane v equals 9. I hope this makes sense. If you have any questions, let me know. I hope to make another video on the next section. I think the next section is on triple integrals. I hope to explain it nicely. Okay, have a nice day. I hope you're saying I hope you had a nice weekend, and I hope your family is stay safe and healthy. Bye bye.